Hello students. So today we are starting with the new topic, that is vector algebra. Okay, so you should know what is a vector and a scalar. Okay, so from our 11th standard, that is from physics, okay, we have learned that a vector is a quantity which has magnitude as well as direction. So vector is a quantity which has magnitude and direction. Okay, and scalar is a quantity which has only magnitude, no direction. Okay, so magnitude means it is the value, okay, value of that quantity, and direction it is positive or negative, that way. Okay, and scalar you can take example as distance. Okay, distance, if we measure from this to this and also from this to this, it will be same. We never take it positive or negative, right? But force, if you take the case of force, then we have applied force in this direction. In this direction, if you are applying it in forward direction, it will be positive. In backward, then it will be negative, right? So it has magnitude as well as direction. So this becomes your vector. Okay, so vector, if vector AB is there, okay, directed in this direction, then it is denoted by AB bar, or if the direction is from A to B, then the arrow is like this. Okay, and if it is given some A, then we denote it as A. Okay, so this is the way vector is denoted. Okay, now this point A is called the initial point, and point B where this ends is called a terminal point. Okay, now the distance between A and B, okay, that is from initial point to terminal point, is called the magnitude or the length. Okay, magnitude or the length of the vector, and it is denoted by mod of AB or A, like this. Okay, and arrow denotes the direction of the that is direction from A to B. So this is always positive, that is greater than 0, because 0 means no distance, because this is a distance or length, right? Okay, next subtopic is position vector. Okay, now vector means we are in 3D. Okay, so in 3 dimension, x, y, z. Okay, suppose there is a point P with coordinates x, y, z, and there is a line from the origin. Okay, so this is our vector. Okay, so OP vector is your position vector, that is vector P, vector of P with respect to O. Okay, or it is denoted by R. Okay, now it's this thing, distance is given by, or the length is given by using distance formula, which we have learned in coordinate geometry, right? That is root of x2 minus x1 the whole square, then y2 minus y1 the whole square, plus z2 minus z1 the whole square. So here origin is 0, 0, 0, 0, 0, 0. So this will be 0 minus x the whole square. So it is x square plus y square plus z square. So this is your magnitude. Okay, now this vector r, okay, makes angle alpha with x-axis, makes angle beta with y-axis, and makes angle gamma with z-axis. All are positive. Okay, then there is a term called direction cosines, that is, right here, direction cosines. Direction cosines are given by cos alpha, cos beta, and cos gamma. Okay, so these are direction cosines, and they are usually represented by L, M, and N. Okay, next we have direction ratios. Okay, so direction ratios are given by cos alpha equal to x upon r. Okay, if you take this that is ratio of x with the mod, that is length of the vector. Okay, so then r is multiplied here, cos alpha is your L, right? So LR equal to x, then LM equal to y, and LN equal to, this is MR, NR equal to Z. So these are your direction ratios. Okay, LR, MR, and NR, and denoted as A, B, C. Okay, so there is one equation, that is L square plus M square plus N square is equal to 1. So you can make use of this equation while solving the problems. Okay, let's write one example. Say vector is given, a vector, suppose 3i plus 2j plus 1k. Okay, so this is the vector. Now these are your scalar components. Okay, 2, 1, and 3, 2, and 1. Together with this, that is 3i, 2j, and 1k are called vector components. Okay, now if you want to write magnitude of this, then it will be root of 3 square plus 2 square plus 1 square. So it is 9 plus 4 plus 1, root 14. Okay, let's write types of vectors. Okay, types of vectors. So first one is your zero vector. Okay, whose initial and terminal points coincide, that is there is no length, so it becomes a zero vector and it is denoted by O. So its initial zero vector, so its initial and terminal points collide, so this is your zero vector. Okay, so now second one is your unit vector. Unit means 1. So a vector whose magnitude is unity, okay, it's called a unit vector, and it is denoted by A cap. Okay, then we have co-initial vectors. Co-initial vectors means 2 or more vectors having the same initial point. So your AB vector and your AC vector, okay, they both have same initial point, right? So these are called co-initial vectors. Then we have collinear vectors. Two or more vectors are said to be collinear if they are parallel to the same, okay, same line, irrespective of their magnitudes and direction. So if you have a line, say, and this vector is there, one vector, and another vector is there, and both are parallel to this line, and they have said that irrespective of their direction, means if one vector is in this direction, one vector is in this direction, it doesn't matter. Okay, so these are collinear vectors. Then we have equal vectors. So equal if their magnitudes are equal. Okay, so if they have the same magnitude and direction regardless of the position of their initial points, so they have equal magnitude and also equal direction. Equal. Okay, then we have negative of a vector whose magnitude is the same as that of the given vector. Okay, its magnitude is same but direction is opposite, that is AB vector is there and one BA vector is there. Okay, both have same magnitude but they have different directions, right? So we can write BA vector as negative of AB vector. Okay, so these are the types of vectors.